Alright, welcome to the first lesson of the second unit where we're talking about programming structures or structured programming. Today we're going to be talking about the selection structure. So normally when we write our code is executed by line in the order it appears, kind of like reading a book. You start at the top, that's the first thing that happens, the next line of code that we see is the next thing that happens, and so on. But sometimes when we write programs, especially more complex programs, we want to change the behavior of our program based on a decision that happens. So if something's true, I want to do this, and if it's not, I want to do something else. Sometimes we also want to repeat lines of code over and over and over again. To do these things, you have to adjust the flow of your program using what we call program structures. There are three basic programming structures that we can use. The first is called sequence. This is where lines of code are executed one by one in the order they appear. This is the type of programming we have been doing so far in our programs. The second type of structure is called selection, and that's what we're talking about today. This is where we make a decision whether or not to do something, and based on whether that decision is true, we run one section of code or we run a different section of code. And the third programming structure that we'll be looking at in the upcoming weeks is called repetition, where a block of code is repeated over and over again. So selection structures. A selection structure is a point in the program where we compare two values. And based on that comparison, the flow is executed one way or another way. The comparison we make is always going to give us a Boolean result. It's always going to either be true or false. There are two types of selection structures we can use. The first one, and more common, is the if statement. This is where we're going to have a question, and it's either going to be true, so we do this, or it's not going to be true, so we don't do it. The second type is called a switch case statement, where I'm going to choose one of a number of options that are available to me. This is like using a menu system. But before we can do any of these programming selection structures, we first need to understand how logical comparisons are made in Java. When we want to make a logical comparison, we do so using a relational expression. And this relational expression is usually found in the first line of your if statement, surrounded by smooth brackets. If that relationship is true, we're going to execute the statements that follow it. If it's false, we're not going to execute the statements that follow it. The relational expression contains these symbols: greater than, less than, equal sign, and not equal to. Now, I'm going to go back to grade 2 math here because I guarantee you at some point someone in this course is going to make the mistake of using the wrong symbol. To remember the difference between greater than and less than, think of this sign as an alligator's mouth, and the alligator is eating the larger thing because it's a very hungry alligator. So in this case, variable 1 is greater than variable 2 because it's eating it. In this case, variable 2 is greater than variable 1, so we've got variable 1 is less than variable 2. Again, I'm eating the larger value. It's important here when you're working with the equal sign to check to see if things are equal, you have to have two equal signs. If you only use one equal sign, it's no longer a test for equivalence, it's an assignment operator, where I'd be taking something on the right side of the equal sign and storing it in a variable on the left side of the equal sign. So one equal sign will make them equal, two equal signs checks to see if they are equal. So how do I use the if statement? The if statement, I've got a single case statement. So in other words, I'm going to check if something is true, do this statement. So here's an example of what it would look like in Java code. So I've got my variable integer called mark. It has a value somewhere. I've given a value somewhere in my code. Now I'm going to check if my mark is greater than or equal to 50, I'm going to output you pass. Notice the format here. Anything that comes after that selection statement is started with an open squiggly and ended by a closed squiggly. Okay? And whatever code I'm doing inside that if statement must be indented and lining up so that I can easily see where my if statement begins and ends. I can do multi-line statements, which is exactly the same as the one before. The only difference is that I'm now doing more than one thing if my expression is true. So in this case, if my mark is greater than or equal to 50, I'm going to print what your mark was as well as telling you you pass. And I can have as many lines of code as I want inside any particular if statement. I can have an if-else statement which checks to see if my expression is true, do this. Otherwise, if the same expression is not true, do something else. So let's look at our example. If my mark is greater than or equal to 50, I'm going to print you pass. Otherwise, I print you fail. Notice that there is no expression here between the else and the open squiggly. It's basing it off of the initial expression that I had above. And the last one I can talk about is the if-elseif statement. If something is true, do this. Else, if something else is true, do this. And I can have as many of these else if statements as I want. And then finally I end with an else statement saying, if none of the things above are true, do this. Okay. In this case, it's important you use if-elseif statements if your expressions are related to each other. Okay, so I want to check, like, if one mark, if another mark, if another mark, if another mark, I can do this because those are all talking about marks. But I don't want to do something based on if you are this old, and then else if you are this age, and then else if you are a boy or a girl. Because if I do that, boy and girl has nothing to do with ages. They should be separate if statements. So here's an example. If my mark is over 80, I'm an honor student. If my mark is less than 80 and my mark is over 50, I pass. Otherwise, I fail. This line here is an example of what we call compound checking, where I can check multiple conditions at the same time. And I can do as many of them as I want in a row. So the one we just saw here is AND. This tells me I'm going to get true. The entire line is going to be true if both of those conditions are true. If either one of them is false, then the whole thing becomes false. I can also use the OR statement. In the OR statement, I'm going to get a true answer if one expression is true, or the other expression is true, or both of them are true. I have one for false, which will give me a true answer if my expression is false. So if this is false, I get a true. In other words, this works if it's not true. The caret symbol, which is found above your number 6 key, is used for either one or the other, but not both. Okay, it'll only give me true if one or the other are true, but not both. So in other words, it would be true if you are stupid or you're Mr. Burns. But it can't possibly be both because there's no way that Mr. Burns is stupid. Okay? And this last one is very, very rarely true. I have an expression, and if it's true, it gives me this value, and if it's false, it gives me this value. Very rare that you'll use this. The most common way to use it is when you're trying to convert between integers and Boolean expressions. So you don't really need to know this one all that well. These top 4 are the ones that are a little bit more important and more commonly used. So the other type of comparison that we had was a switch case statement. A switch case statement is used when you have a large number of options to choose from. It's made by testing a particular integer against a number of different constants or a number of different options that you could have. And if we have a match, then the things I want to do as a result of that match are executed. And I keep on executing statements until I reach a break statement, which leaves the entire switch case block of code. So here's what it looks like. Again, in general, my keyword switch, and here's the variable that I'm going to be checking. And then I'm going to provide all the different options that it could be equal to. So I'm going to check to see, does value equal this value? If so, do these things. Or does it equal this value? If so, do these things. And I keep giving multiple cases until I'm done. And then if it didn't equal any of the things above, I can do these statements. Let's see what that looks like in an example. So again, I'm going to have a mark that I'm going to be checking. If the mark is an 8, a 9, or a 10, I'm going to say you got an A, and I'm going to break. If it's a 7, I'm going to say you got a B, and a break, and so on all the way to the end. Now you notice in this case, I've made a couple of syntax errors. What I've forgotten to do is I've forgotten to put break statements under each of these lines. So if I were to actually run this program, and the person had a mark of 6, my output would be you got a C, you got a D, you got an F, invalid mark, all one after the other, because nowhere does it break out after I'm finished. It's also possible to use a character instead of an integer to check through my switch case statement. So for example, if I didn't want to use numbers, I could have a menu system where you have to give me a letter. So choose from S, C, L, or F to do one of these things, and then in that case my cases will be labeled as S, C, L, and F. Again, be careful that you're using single quotes here, because a single quote represents a character. If you use double quotes, it's going to think it's a string, and you'll get a syntax error, and it won't work. That's it. That's all we have to talk about today with regards to selection structures. We'll see you in class tomorrow where we can test it out.